Hello and welcome back to another video. This is just kind of like a little one-off video for Numworks checks suggested by someone in my comment section. Thank you very much for the suggestion. I have a decent amount of stuff to share. This is also because we the A1 singles summer exam is in a couple of days, so I wish everyone good luck for that. And I have a little section at the start of the video where we focus on the content for just A1 singles, and then we'll move on to the other bit of the content. So, to start, there are three things. Right, so my PowerPoint's still working. Great start. Hello? Right, better. There's three things that are the most important features that you can check like 50% of questions with. And obviously this is all about checking and not about solving. There's some things you can obviously solve and then you can get the answers with your own working, but you shouldn't just be obviously just solving stuff and then writing the answer down. You're better than that. You know that you're not supposed to do that because you will not get any marks for just writing the answer down. And this is all for checking unless stated otherwise. So these three things. Equation solver firstly. So this is pretty simple stuff. Nothing too complicated. On each slide, on most slides, I have this little thing on the right showing how you actually put it in, and then an explanation on the left. So just read all this stuff. So putting in the original equation, so not stuff that you've manipulated already, just in case you made a mistake, and checking to compare your answers. And if you see that the answer's wrong, just keep going one step further into your working and putting the equation in until you find where you've made the mistake. For hidden quadratics like this, another thing, because the hidden quadratics are the main thing you'll use this for. So like here, for example, this is a classic kind of projectile setup. You can just replace whatever is hidden in the quadratic, so in this case sines or tans here, and just replace them with x's. So here you'll get sine. If you put this, it will give you x equals 2, x equals 1. But then in your thing, you'll write down sine x equals 2, sine x equals 1, and then solve from there. There should not be a 4 there. Number 2, the grapher. So this is, again, the other probably most important feature. Probably the most important feature, honestly. So it's very, very useful so obviously model questions is very useful because you can just plot the model, or if you're finding values in the model, you can plot your model and see if your model is correct by comparing the values in the question. Or for questions like this, so this is an example question, this is some binomial expansion. So you can you'll put the original equation, and this is like my answer, in the grapher. It will give you something like this. Sometimes the blue one will be over the red one, and you can check either, you can zoom out a little bit, because you can't actually see here, but the blue curve is actually just inside the red curve because they're the exact same, because that's how it will work if they're the exact same. And then you can go to the table function, and you can see that the values are all the same, and therefore your answer is correct. And then for distributions, just mentioning it because this is like the most streamlined thing. This is the thing that everyone uses the calculator for, so I'm not going to go into detail with it because you've probably learned about it in class to death. So, yeah. Right. Do not leave if you're in, or don't skip if you're like A1 doubles or A2 singles yet, because the content I'm going to go through here, I'm not going to go through again. So just this little bit here. So this is the topic list for the A1 singles summer mock. Ignore the highlighted stuff because this was a bit outdated. And and I'm going to highlight all the things that either you can just check. Blue is going to be things that you can check with the things I just mentioned, and red is going to be stuff you either can't check, so stuff like vectors and like mechanics, which I've just highlighted red here, or stuff that you just check by putting numbers back in your calculator and seeing if they're right. So this is all going to happen. So as you can see, a lot of this stuff you can just check with the stuff I've already said. But now I'm going to go through all the different like specific ways and specific text to be able to check everything. So firstly, graph transformations. This is a pretty simple one. If you have something you want to transform it, just put it in the grapher and then transform it, and you can check points. You can you can put points in the grapher. You can put like curves in the grapher and do transformations on them. Next, binomial expansion. This is a big one. So this is also, there's a little bit of extra stuff for A1 doubles, but firstly, just for singles, the finite binomial expansion. So firstly, for n choose r or n choose k, whatever you want to call it, you have to use this kind of like order to find it. It's quite annoying to find. And what have I said? Oh yes, also for approximations, this is just another thing to touch on. So if they ask you to approximate a value with your expansion, just like put it into the actual thing, and put it into the pre-expanded version and then your expanded version. And if they're close to each other, then your expanded version will probably be correct. But also, so you see here, the red curve here is the thing in the brackets, and the blue curve is my approximation with the binomial expansion. So as you can see, they're not close to each other because this entire thing, it was like to the power of 9 or something, but I only expanded up to the first 4 terms because that's what the question would ask. It would ask first 3 terms or first 4 terms. So for A1 singles, all you really need to know for this checking is that they will be close to each other when x is close to 0. That's when they're going to be close to each other, the two graphs. So here, this is likely to be correct because the blue curve touches the red curve when they're close to 0. After around like 0.2, they do diverge, but again, A2 singles and A1 doubles, you know why that is, because that's more to do with the infinite binomial expansion and the range of validity. And you'll kind of understand more why this works, but this also applies to infinite binomial expansion. So if you plot the first few terms and you plot the actual thing, then it should be close to each other when it's close to 0, and your answer will likely be correct. Radians, so just remember to be in radians and degrees. The calculator, it's unlike the Casio, which you just like, it's just like GG, you lost all your marks if you are in the wrong mode, but the Numworks makes this a lot easier. So here you see I made some mistakes. I've done radians when it should have been degrees, and degrees when it should have been in radians. And yeah, it will tell you basically. So here it says rad, here it says the little degree thing. So just be careful with that, make sure you're in the right mode, and yeah, move on. So differentiation, this is a big one. There is a numerical differentiation function in the toolbox that should be pretty, like, no, you go toolbox and then calculus. So obviously you can use this as something that I don't see many people do, where if you have an expression for dy dx, if you substitute like 2 or 3 random values into your dy dx and then do the dy dx on your calculator and substitute the same values in, if they're the same, then your answer is probably correct. So another thing, what else? Oh yeah, so, wait, what the? Oh yeah, sorry. So there is a tangent function, as you can see on the image. There is a tangent function that you can find tangents on graphs, which is pretty not known very well actually. And again, why I said this is more useful for A1 singles is because when you have A2 doubles, A2 singles and A1 doubles, you're gonna have curves that you're going to have to do implicit differentiation, where some of the curves it won't allow you to put tangents on them because the curves are too complicated for the Numworks to put tangents on them. But with A1 singles, 99.99% of the time you will be able to use this tangent function just because of how the curves work and like the knowledge of differentiation that you have so far. And also you can use the calculate find, that you can find obviously tangents, maximums, minimums, and stuff like that. Next, integration. So this is same thing with differentiation. There's a numerical integration function in the toolbox, and you can do it on graphs for a more visual thing. This is much less useful than the differentiation function, but it's just a nice kind of visual thing, so you can see. It helps a lot maybe with negative areas. It helps a lot. But yeah. Yeah, that's really all I'm going to say for this one. And finally, vectors. So this, you can't, with the current content that you know from vectors for the A1 singles, there's nothing that you actually can do with vectors. But if you learn for A1 doubles specifically, and maybe some people that have learned ahead, you can do dots and cross product on the calculator. So here, and you can use this button here, shift, and then this button to write vectors into your calculator. If you don't understand what I just said, don't worry, because you don't actually need this knowledge. But unless you're in A2 doubles, but that's not what this video is targeted. But yeah, that would be vectors. You can't really check vectors. It's just kind of a little addition if you know to do these things. And I think this is the last one for A1 singles, data representation and presentation. You can use the statistics function, which is underutilized, as it says here. And you can use yeah, you can, and it's pretty simple. There's not much I can really say. You just put it in and you get all the stats from it. Okay, just note on this point here, if it is group data, so which it usually is, so if it's frequency, or no, if it's frequency, if it's like if there's a class width, then just plot the value here, just put in the midpoint of the class width, because you can't plot group data on the stats function. And also this button here doesn't exist on your version, so don't worry about it, the type of data button. Yeah. But make sure to be reading all this, by the way, because I'm not saying absolutely everything that's here, because I don't just want to repeat what's on the slides. Next, all right, so that is A1 singles done. Now we're going to move on to A2 singles and A1 doubles. So this is the entire A-level specification, including A1 and A2. So I'm going to do the same thing I did earlier, where so the blue things that have been mentioned. This is a bit different. So blue is things that I've just said already. Red are things that are uncheckable, blah, 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 same thing earlier. And then the yellow box is stuff that is kind of the old blue box, where it's stuff that you can check with either just the normal grapher, the normal equation solver, or the distribution function. So we're just going to do this, so make sure you might have to go back a little bit. So all this stuff is blue. So you can see a lot of the stuff we've already mentioned, and then this is all the red stuff, so basically all of mechanics. And then this is all the stuff that we've that are checking by the simple methods at the start of the video, and I think that is everything under these two as well. So everything that isn't highlighted, I will be going over in detail now. There's that as well. All right, linearization. So this is such a small little bit of the spec that for some reason comes up a lot. So it's a bit annoying. So with linearization, obviously you get your exponential or your quadratic model, and you can turn it into a logarithmic model. So you can do stuff like you think you can just do your normal modeling stuff where you plot both of them, and it turns like this, where you have the graph being the same and using the table function to check. However, you can't, as you can see on the left image, you can't use the you can't do the middle image by using the normal equation that they'll give you in the exam, because it'll be log base something equals blah 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 with a log. So, but because it's, as I said here, the Numworks really doesn't like equations that are in the form that aren't in the form y equals f of x. So you can turn it into y equals f of x by just raising both sides under base 10, and the log or the base, whatever the base of the log is. So here you can see this doesn't work, but this green thing here at the bottom does work, and it's the exact same. I've just rearranged it a little bit by using log laws, or not log laws, by just doing 10 to both sides, and then this is the exact same as this. And then now you can do the middle, the thing in the middle, where you compare the quadratic / exponential model with the logarithmic model, and then you can get something like this to actually check your model. Sequences and series, another big one here. This is another very important function, the sequences function. So you can use, firstly on the right image there is a summation feature that you can use, but you can also use the series function, which or the sequences function, to help you kind of visualize it. This is much more helpful in numerical methods, but which is going to be in a minute. But just make sure you can use this. You can see what's going on. But you can basically do everything with this, and as it says here, sums to infinity. So if you want the sum to infinity of a sum, like, not 9k squared, because that'll just diverge, but if you wanted the sum to infinity, you just put like 99999 at the top. Don't make it too big, otherwise it will just be stuck loading and your calculator will basically crash. But put like 5 or 6 digits or something like that of nines, and then that'll give you a pretty accurate sum to infinity. If it's asked for that. And then this thing at the bottom, this is incredibly important for numerical methods and for sequences and series. If you're going to use the Numworks for sequences and series, make sure you're looking at the right term. For example, if you put a sequence in and it says, like in the exam, it says u0 equals 6, on the Numworks, the first term is u1. So you want to put u1 as 6, and you have to go one term ahead. So for example, if it asks for u3 in the exam, you want to find u4 on the Numworks, because it's in one term ahead. You could do this by just counting up terms, being like, oh, this is u0, so therefore this is u1, this is u1, therefore this is u2. But it makes more sense when you kind of look at this thing here when you go across and you'll see what the terms are. Obviously, or you can just do it in your calculator normally if you think this is too confusing, but it does really help if you get used to it. Next we have, I think, parametrics. This is just a quick little thing, how to type parametrics, because I see people struggle with this. You can't just do y equals function of t, x equals function of t. That doesn't work. You have to do it like this in coordinates. So this top red thing is what happens when you press execute or OK on this one. So you want to type it in coordinates where the x equation is on the left and the y equation is on the right. On your on your thing. So maybe in the exam it will say x equals 7 cos 2t, y equals 8 sine 3t, and this is how you plot it on Numworks. And you can do the same thing. You can find tangents, you can find areas, you can find whatever. Yeah, and that's all I'm really going to say, because you can just check it like normal with all the other stuff I showed you earlier. Back to the sequences function, numerical methods. This is something that's much less known. Firstly, iteration you can do in your calculator. Instead of having to just type it in a million times, you can just put it on the sequences function and just press like right in the graph, and it will tell you like the first few terms. Or you can go to the table and it will show you the first few terms. Just keep in mind the one term ahead thing again. So as you can see here, you can actually see it's u1 equals 0.22, but in the exam it would say u0 equals 0.22. So you again have to be one term ahead. And so you can see this is like a little graph, and you can actually do staircase and cobweb diagrams on the Numworks, as you can see here. And you go to say graph, calculate cobweb diagram on the sequences function. You can see here, and if you just keep pressing execute, it will add X more staircases or more cobwebs to your curves. This is incredibly useful because it helps you like do the diagrams if you forget how to do them, because a lot of people do properly because they're pretty irrelevant. But yeah, that's going to be numerical methods. It's a lot of people waste a lot of time on numerical methods just because they're typing it really inefficiently into the calculator. You can also do Newton-Raphson like this, by the way, as well, by just putting it onto the sequence function and looking at the values. I think this is the last one, trapezium rule. This is just another quick one. So for example, this is an approximation of this integral here, this thing down here. So you can see that I put the original integral in, and then I put my trapezium rule calculation in, and you can see that they're very close to each other, so this is likely correct. As it says here, you can't fully know that your approximation's correct, because you can make a little mistake and it would affect the answer to an extent that you would think that it's right. But again, it helps. It's better to do it than to not do it, because you might here, if you did it wrong, you might get 28, which is obviously not going to be correct, unless you do one strip. So yeah, and I think that's going to be it. So thanks for commenting, whoever did that. Happy to share all my Numworks stuff. Again, if you're running out of time, or not again, I haven't said this yet. If you're running out of time, you don't have to do all this, but what I do personally, I do it after every single question. I check the question on no matter how easy it is, I check it using one of these three things on the Numworks, especially in Pure, because with everything except vectors, you can check on the Numworks. So I end up just checking every single question after doing it instead of looking back at the end, because I find that when I'm going back at the end, I just can't be bothered to check anymore because I've done all the questions and I can't be bothered to look. So I just do it after doing the question. But if you feel yourself running out of time, especially if you don't race through the first few questions, because with the new exam system, you should be racing through the first few questions. But if you're not racing through them, you should definitely spend some more time actually doing the later questions instead of checking the earlier ones. But yeah, that's all from me. Good luck in A1 singles exams if you're on A1 single, and good luck in your A level for A1 doubles and A2 singles. I'll probably upload a little bit more before then, and I will see you next time. Goodbye.